Good day, class. Back to our topic of discussion under resultant and equilibrant. Last class, we dealt with 3 cases so far under resultant, and here we have examples to be solved under the 3 cases. The first one, we have a body of mass 5 kg is acted upon by forces of magnitude 2 Newton, 7 Newton, and 9 Newton along the same direction. We now have to find A, the resultant force, B, the acceleration. Now, this is case 1. Case 1 in the sense that all the forces are acting along the same direction in the question. So we said in last class that whenever we have forces that are acting in the same direction, if we ask to find the resultant, we sum all the forces together because they are acting in the same direction. So summation will give the resultant of forces that are acting along the same direction on a body. So we have our 2 plus 7 plus 9 to give us 18. Everything is 18 Newton. Now, the value of acceleration, we have our F to be equals to ma. That is the mathematical formula that connects force, mass, and acceleration together. So we make A the summation of formula there. We have our A to be equals to F all over M, and that will be 18 divided by 5. When we punch our calculator, we have 3.6 meter per second square. Units are very important in physics, like I've said. So force is in Newton, acceleration is in meter per second square. Question number 2, we are given a diagram. And it says the diagram above is a system of body mass 7 kg acted upon by different forces as indicated. We now have to find A, resultant force, B, magnitude of the acceleration. If you check the diagram very well, we see that we have two forces that are acting in the same direction. 8 and 2 are acting in the same direction, while 3 is acting in the opposite direction. So the first thing to do, will resolve the 8 and 2 that are acting in the same direction to give us 10. We're going to add, since they are acting in the same direction, so we have 8 plus 2 will give us 10. So here we'll now be having 10 Newton in one direction and 3 Newton in the opposite direction that we've seen here. So what is now the resultant? Since they are acting in the opposite direction, we subtract. Subtraction will give us the resultant of forces that are acting along different directions on the body. So here we have our 10 minus 3, that will give us 7 Newton. What is acceleration? Acceleration equals to F all over M. That will be 7 over 3, which will give us 2.33 meters per second square. The third question, whilst we are given two forces of magnitude 4 Newton and 3 Newton, they are inclined perpendicular to each other. Find the resultant force. This is the diagram given. We all know that whenever forces are inclined perpendicular to each other, it means they will form an angle of 90 that exists between them. So in that case, we are going to be using what we call Pythagoras theorem to solve. To find the resultant of forces that are acting perpendicular or they are inclined perpendicular to each other, we are going to be applying Pythagoras theorem to find the resultant. So from there, we have the diagram being resolved further. So 4 Newton acting upward, 3 Newton acting in the east direction. So here we have our r square equals 4 square plus 3 square, which gives us 16 plus 9. 16 plus 9 is 25. Then r will be equals to the root of 25, which will give us 5 Newton. Now, case 4. Now, we've done 3 cases earlier, so this is the 4th case. The 4th case is the exertion of forces inclined at an angle of theta to each other. So we have the diagram here. Whenever forces are inclined at an angle of theta to each other, we're going to be having what we call horizontal resolution. We're going to be having what we call vertical resolution. If you check the diagram, we now resolve it further. F1 is vertical, then F2 is horizontal. F1 is moving upward, that is vertical. Then F2 is horizontal because you can say F2 is formed on the x-axis and F1 is formed on the y-axis. So from there, Using our car course, we have cos theta will give us adjacent all over hypotenuse. Where is the adjacent? F2. Where is the hypotenuse? Our R. Then from there, we make F2 sum of formula, we cross multiply. F2 will be equals to R cos theta. Take note, F2 is what we call horizontal component of the resultant force. Why? Because F2 is formed on the x-axis. Anything x is what we call horizontal. Now, similarly, we have our slope. Sin theta will be equals to F1 all over R, where sin means opposite all over hypotenuse. F1 is the opposite, R1 is the hypotenuse. When we make R1 sub of formula, we cross multiply, we have our F1 to be equals to R sin theta. What is F1 called? F1 is called vertical component of the resultant force because F1 is on the vertical axis, and anything on the vertical axis is taken to be our y. Take note, whenever forces are inclined at an angle of theta to each other, we are going to be having horizontal component of the resultant force and vertical component of the resultant force. In the next class, we shall apply this formula to solve questions. Thank you.